We're going to go ahead and discuss partial fractions here, which is a technique of integration. So, you have this problem here, which is where we use partial fractions on, and, for us, we haven't learned anything up to this point that we can use to find this antiderivative. I know you can use trig substitution for this, which is really crazy and difficult on this one, and much easier to use partial fractions. So, the first thing we want to do is essentially just manipulate and rework this to look like something else. It'll be the same, but it'll just look differently in order to be able to integrate it. So the initial stuff we're going to do right here, I'll kind of divide this up here. All of this over here is just going to be manipulating, and in order for us to get it to look differently, it's not integration at all. So how partial fractions work, start out by factoring out the bottom. So in this case it's going to be x minus 3 times x minus 2. So I'm going to write this out as 1 over x minus 3 times x minus 2. So again, I'm just basically writing this whole thing right here, just factored out. And then I'm going to go ahead and set this equal to a over x minus 3 plus b over x minus 2. And essentially our goal for the partial fractions portion of it here is to rewrite this in this format. So rewrite this as now two separate fractions, and what we need to do is figure out what denominator do we need in order to make this equivalent and make that side have two separate fractions. Alright, so that's the first step in writing it out. And the next thing you're going to do here, just kind of move this dotted line up a little bit, so there's some space for this next thing, is you're going to multiply both sides by the denominator right here. So multiply the left side times x minus 3 times x minus 2. Multiply this entire right side by x minus 3 times x minus 2. 3 right there. Can you see that? Okay, now on the left-hand side, works out really nice and easy. These just cancel out, and that's obviously because we multiplied by that, and we're left with just 1. On the right-hand side, we have to multiply this whole thing right here by this first term and by this second term. So what we're going to do here first, let's multiply this times a over x minus 3, and when we do that, the x minus 3 will cancel out. We have one on the top, one on the bottom, they're going to cancel, so we'll just have the a and the x minus 2. So it will be a times x minus 2. Plus, and then we need to multiply this times this b over x minus 2 term, so again the x minus 2's here will cancel. Now we'll just be left with b and an x minus 3. B times x minus 3. Okay, so all these steps are going to look a little strange until we get to the end here, but then hopefully you'll see what's going on. Right now I'm going to just go ahead and distribute everything out. So 1 equals ax minus 2a plus bx minus 3b. Then I'm going to go ahead and find my like terms, which is the ax and bx. They each have an x, so they're like terms. The other ones don't, so they're like terms as well. So 1 is equal to ax plus bx minus 2a minus 3b. Next up here, I'm going to go and factor the x out of these. A plus b times x minus 2a minus 3b. Okay, so far we're manipulating and so forth, and again, we're not quite sure where we're getting. Our goal is to figure out what is a and b, and you'll see in a second we'll get to that. Alright, now, what we're going to do is we're going to use the idea of, in an equation, which this is, the left-hand side and the right-hand side are equal to each other. They're equivalent. So I'm thinking, okay, I see an x on this side, there's no x over here, so, I could rewrite this, if I wanted to, as 0x plus 1. So that's the same thing as 1, because 0x is just nothing. The reason I'm writing that is to show that, okay, the left and the right side have to be equal. Since, there's an equal side, they've both got to be the same. So on the right side, I see an x here, so the number in front of x is a plus b. On the left side, I see an x, the number in front of x there is 0. So that means that, on both sides, the numbers in front of x have to be the same, so that means that a plus b has to equal 0. Write that right here. A plus b has got to be equal to 0. And then there's the constant terms right here, which on the right side are made up of negative 2a minus 3b, the left side is just 1, so those have to be equal to each other. Negative 2a minus 3b has to be equal to 1. Alright? Okay, so now the cool thing here, I have two equations. My two unknowns are a and b, so I can solve for them. So you can either use, it's solving a system of linear equations. So, like, you don't have to use a specific method, but you could, for instance, multiply this top equation by 2, noticing that this one is a negative 2a, and add them together, that'll cancel. A lot of times people use substitution, so I'll go and do substitution on this. So in this top equation right here, I'll subtract b from both sides. And if I do that, I'll get a is equal to negative b. So again, I just brought the b over the other side by subtracting. So what I'll do is I'll substitute that negative b in where I see a. So I'll have a negative 2 times negative b minus 3b equals 1. So I substituted that into a in this equation here. Now I'm just going to simplify this out and solve for b. So I get 2b minus 3b equals 1. Negative b is equal to 1, so that means that b is equal to negative 1. Alright, very nice. And I've learned up here already that a is equal to negative b, so that's going to be fairly easy for me to just figure out what a is. A is just the opposite of b. B is negative 1, that means a has got to be equal to 1. Okay. So, I know that was kind of a lengthy process right there, but what we have found is that a is equal to 1 and b is equal to negative 1, so that's what I'll do. I'll take 1, put it back up here in for a, negative 1, put it right here for b, and what I found is something that's equivalent to what I started with, just right here, but looks different and will be easy for us to integrate. So let's see here, I'm going to do the integral of 1 over, spacing out here, integral of, so a is 1, so it's going to be 1 over x minus 3 minus 1 over x minus 2. Okay? So again, what I did was, instead of writing it like this, I wrote it like this. They're the same. This process led us to something that's the same, something that's equivalent, just looks different. I want to make sure very clear of that this is the same as this. Over here was no integration. We didn't integrate yet. All we did was find a replacement for this that makes it easier to work with. So in order to integrate this, I think it's easy to split up into two integrals, which we can do since it's separated by either plus or minus, in this case a minus. And now it's real simple. They just follow the natural log rule, where I talk about how if the derivative of the bottom is equal to the top, then it's just the antiderivative is just natural log absolute value of the bottom. So this is going to be natural log absolute value of x minus 3 minus natural log absolute value x minus 2 plus c. And one thing I want to point out here, so this is technically the answer. We're done. We found the antiderivative. One thing I'd like to point out is that this is usually not how you're going to see the answer. So a lot of times they'll have a question like this as a multiple choice on a Calc BC AP test. But they probably won't have the answer choice looking like that. They probably will use the natural log rule. Let me squeeze it in right here. It's the natural log of A minus natural log of B equals natural log of A over B. So there's a few of those natural log rules, and that's one of them. And that's what they will use here. So they'll probably write it like this. So I don't want you to get to a problem on an AP test and think, oh my goodness, I can't find my answer choice here. I know I did it right. It's nowhere to be seen. Make sure you are familiar with this natural log rule right here. Okay, so that's a pretty, pretty basic general problem for partial fractions.